All right, you guys, so we are going to take a look at a new topic today, but before we do that, I want you to try this warm-up just put it on your conditional probability worksheet. So you've got this table there, and I want you to find the things listed below. So the probability that you have a car phone user, the probability that you have no violation and a car phone user, and so on. Keep doing all of those, practice our probability ideas and our conditional probability ideas. So pause the video, attempt this problem with the contingency table, and then play it when you're ready to check your answers. All right, so when I'm looking at the probability of having a car phone user, for all three of those first three problems, I'm looking at the grand total of 755, okay, as my denominator. And then I'm just looking for how many of those 755 people are car phone users, and well, that's just 305. So you're going to see that my answer is 305 over 755, and that as a reduced fraction or a decimal can be simplified, but that's how you get to your answer. So don't leave it like this, either reduce that fraction or change it to a percentage, but that's where you should start. Okay, the next one is the probability of no violation and a car phone user. So when you're looking at this one, you need to find somebody who will answer yes to both of those questions. So I'm looking for people that both of these things apply to them. So I've got just these 280 people that are car phone users and have no speeding violation. So 280 out of 755. Okay, next, no violation or a car phone user. These are people who would answer yes to either question, maybe both. Okay, so I need all of my no violation, so all 685 of these people, plus the additional 25 that are also car phone users but don't have a speeding violation. Okay? The other way you could do this is do 685 for your no speeding violations, plus 305 for your car phone users, and then subtract the 280 that you double counted. No matter how you do it, you should have gotten an answer of 710 over 755. Okay, last one is a conditional probability, and those conditional probabilities are the situations where your denominator changes. Okay, so the probability of somebody being a car phone user given that they have a speeding violation. So the only population I care about is the speeding violation. That second thing in my conditional probability gives me my new denominator of 70. I'm only looking at my speeding violators. Of those 70, 25 of them are car phone users, so this probability would be 25 out of 70. Okay, this is your warm-up, and this contingency table idea is what we talked about on Tuesday. We're going to apply that now to something new today. Okay, so we're going to be transitioning into the use of Venn diagrams, and we'll use Venn diagrams for the same types of problems that you would use a contingency table for. They provide more visual cues, but they take a little bit of getting used to, so don't fret if you have a little bit of trouble today. So take out your classwork notebooks, and what I want you to do is go ahead and copy this Venn diagram onto your paper. So you've got one circle which represents phone users. That means everybody who ends up in any part of the circle is going to be a phone user. Anybody who ends up in any part of this circle is going to be your speeding violators. Okay? And so you've maybe seen Venn diagrams before in English class, maybe even science class, but probably not in math before. So we're going to kind of talk through how to set these up. We're going to convert this table into a Venn diagram where my two circles are phone users and violators. Okay? So the first thing I'm going to do is I'm going to put the number 305 in for phone users because that's my total from the table. Then I'm going to look at my total of speeding violators, which is 70. Okay, and so that's going to go in this circle. But you see I circled in red here. This is 25 people who are both phone users and speeding violators. And that set of 25 people needs to go in the middle. They're a part of both circles, so they have to go in this overlap in the middle. When I put those 25 people in the middle, those aren't 25 new people. They're 25 people that are already a part of this circle and a part of this circle. I'm just moving them over to the middle part of the circles. Okay, so I'm going to need to correct these two numbers that are already in there. So I put 25 in the middle, and then I have to subtract 25 off of both of those. So what I would even do is totally erase those numbers and use your new numbers now. Okay? So now that I've got those, I still want to include in here so that I know what my total population was. I want to include the people who said no to both. So I've got a total of 405 people that are not phone users and haven't had a speeding violation. So those people are on the outside of my diagram. Okay? Using this diagram now, I want you to try to answer a couple probability questions. So I want you to take a look at, for me, the probability that somebody is a phone user, the probability that somebody is a phone user and a violator, the probability that someone's a phone user or a violator, and the probability that somebody's a phone user given that they're a violator. What I would suggest that you do is find a way, and I'm trying to see if I have a way to do this, and I'm not necessarily seeing one. Oh, here we go. This might work. Give me one sec. See if this will work. Nope, that doesn't work. Okay, so find a way to like cover up that table so you're not using the table to answer the questions. Try to use the Venn diagram to answer your questions. So pause the video, write down 4 answers to those problems, and then restart it and check them out. Okay, so the probability that I've got phone users, this visual is this. All of my phone users are the people that are anywhere in this phone circle. So I've got 305 out of my 755 again. That might be a repeat from the warm-up. Okay, the next one is the probability that somebody is a phone user and a speeding violator. So if they're going to be an and, they have to be a part of both of those circles. The only people that are a part of both circles are the people in this overlap here, so that 25 out of 755. The probability of a phone user or a violator is somebody who would say yes to either of those questions, and so I'm looking at everybody in either circle and the middle. Okay, that's all of those people. And so when I add those all up, I get 350 out of 755. Finally, the probability of a phone user given that they're a violator. Now I need you to blur your vision and only look at the violator circle here. So we're only looking at this circle. I can block everything else out. Of those 70 people contained in this circle, since that's what's given to me, only 25 of them are also within the phone user circle. So that should be a 25 out of 70. Okay, that should be a little preview for you about how to use Venn diagrams. We're going to do a couple more examples that I want you to put in your classwork notebooks. So when I do this lesson, typically in class, I get some data from my class. So since I'm not there with you guys today, we're just going to have to use the data from my first hour to kind of walk through these problems. So my first hour, there were 33 of us answering these questions. And the first question that we did, you should be copying this diagram onto your paper, is if you like dogs or if you like cats. Okay, and you could like both, you could like neither. What I did first was I'm going to build this diagram from the outside in, and then the next one I'm going to build from the inside out, and I'll show you how to kind of go both ways. I suggest starting on the inside, but here's how you would go from the outside. So the first thing I did is I had everybody raise their hands, and I said, who doesn't like either dogs or cats? And only one person was a hater of both. So I put a 1 on the outside first. Okay, then I looked at them all, and I said, raise your hand if you like cats. And that could be somebody who likes both, but if you would answer yes to the question, you like cats, raise your hand. Okay? The next thing I did is I looked at my class and I said, raise your hands if you like dogs. And I had 32 people raise their hands. Now, this should look kind of weird to you because the first thing I told you was that only 33 people were in my class. And these numbers add up to 54. And so that should tell you something. I've double counted quite a few people. Okay? All I do is I take my 54 that are my counts on here, and I subtract 33, and I get 21. That means I have double counted 21 people. Okay? That means there should be 21 people on the inside that I have to subtract off of both of these. And so what happens is it looked like this, and I had to correct. Okay? I put 21 in the middle, and then I had to correct this to a 0 and correct this to an 11. Okay? So now my Venn diagram is telling a different picture. It's saying there's 11 people who like just dogs, 0 people who like just cats, and 21 who like both, 1 who likes nothing. She liked goldfish, is what she told us. Now, there's a couple pieces of vocabulary that you need to write down. So, the probability of dog with this funny little upside down U, okay, and I didn't draw it super well, but D with a little upside down UC means intersect. So this little symbol means the intersection. And it's asking you about the probability that someone likes dogs and cats. So write that definition down, the probability that somebody likes dogs and cats. And I like that its official name is an intersection. Because if you look at this picture, it's truly where your two circles intersect, is the and. Okay? So 21 out of 33 people like dogs and cats. So the probability of dog intersect cat is 21 over 31. Okay, and this, somebody said, looks kind of like an N. And so they were saying like N, like intersection. And I like that. That's going to help you remember. This right side up U stands for union. U and union. So that kind of makes sense as well. Probability of dog union cat means that the probability that somebody likes dogs or cats. Or cats. So either one. They might say, yes, I like dogs. They might say, yes, I like cats. They might say yes to both, but I want either one. Now, the union is putting it all together. So anybody that's in either circle, 11, 21, and 0, I want all of you as part of my union, as part of my or, my inclusive. So the probability of dog union cat is 32 over 33 for our class first hour. Okay? If you need a minute to keep writing some stuff down, go ahead and pause. Otherwise, I'm going to move on. Just kidding. I'm not going to move on. I want you to pause now and answer these 3 questions about the Venn diagram. Practice using this two-circle Venn diagram. And then you can press play and we'll go over the answers. All right, the probability of cats given dogs is I'm looking only at this dog circle. So I'm looking at only these 32 people. Of those 32 people, 21 of them also like cats. And so my probability is 21 over 32. Probability of cats is anybody in this whole circle. Since this is not a conditional probability, I keep my denominator of 33. And so the probability of cats is just 21 out of 33. The probability of not dogs is what that means. And so I want everybody other than these people in the dog circle. I don't want these people in the dog circle. Well, in our case, there's only one person left who doesn't like dogs. So that one's a 1 out of 33. All right, let's make it slightly more complicated and do a 3-circle Venn diagram. All right, go ahead and take a second, copy this 3-circle Venn diagram down. And what's happening in here is I ask my class to place themselves in this Venn diagram, where the top circle is they have a job. The bottom right circle is they play a sport, and I restricted it to a sport here at Kennedy. And this other circle is that they do an activity, whether it's academic or art. So show choir, band, jazz band, math team, science olympiad, activities like that, academic or arts. So what happened was I started from the middle this time, and I think this is the better way to go about doing a Venn diagram. Start from the middle, work your way out. So I said, if you are a part of all 3 of these things, you have a job, you play a sport, you do an activity, go ahead and raise your hand. And there were 4 hands up in the air, so I put a 4 in the middle. The next thing I did is I said, okay, raise your hand again if you have a job and play a sport. Okay, this time 10 hands went up in the air. No, maybe 6, I can't remember. 6 hands went up in the air, which means that I still have these 4 from before and I just have another 2, so I have to correct it as I go. Okay, then the next thing I did is I said, raise your hand if you have a job and do an activity. Okay, and 6 hands went up in the air. So again, I have to subtract off these 4 that are already counted in that space and put a 2 there. Okay, same thing here, activity and sport, I had 10, so I put a 6 down at the bottom. Okay, then I went through one by one and I said, okay, raise your hand if you play a sport. And I had 17 hands in the air, but I already have 12 of those 17 accounted for in this part of that sport circle, and so I just have 5 extra that are sport only. Then I did the same thing for job and activity. Job I had 9, so I had 1 left to count, and activity I had 16, so I had 4 left to count. At this point, now that you know that I have 33, you can add up all the numbers in here and figure out how many people there are left over that don't do any of those things, though they probably are just focusing all their time on school and homework. Okay, so of the 33 in my class, there were 9 left over that weren't a part of any of these 3 circles. Okay, so take a minute. Now that you have this Venn diagram, pause the video, answer those 4 questions at the bottom. Okay, so the probability that you're in a sport, given that you have a job, I'm looking only at the job circle, okay, and this is the only one I care about. Blur everything out of your vision. So I'm only looking at these 9 people. That makes my denominator a 9, and I want to look then at how many of those 9 would also say they play a sport. That's these 2 spaces, so that's 6 out of 9. Oops. Okay, I guess we're checking the rest of our answers now. The probability of activity union job is anybody who is in either of those categories. So I'm circling it here, either of those two circles. When you add all of those numbers up, 4, 6, 4, 2, 2, and 1, that's 19 out of the 33. Probability of activity intersects sport, as I'm looking where the activity and sport circles intersect each other, right in here. Don't forget about that 4 in the middle. That's part of the intersection. And so that's 10 out of 33 if I add that 4 and 6. And then the probability of a job is just everybody in this circle, 9 out of the 33. Okay? All right, now I want you to work on the Venn diagram worksheet number 2. That's on Moodle. Go ahead and put that in your homework notebook if you don't finish that worksheet. You can go ahead and finish that for homework. So that'll be due tomorrow when I see you guys. My notebook is on the teacher desk up front, so if you need answers, go check that notebook out. All right, see you guys tomorrow.